our friend Joe has changed his tune somewhat. Now he's saying this: Pete will bring donuts to class today if and only if Jenny brings the beef jerky. And we recognize that what Joe's offering us now is a statement of equivalence, a biconditional statement, and we can symbolically represent that with triple bar. We can use triple bar to join up our two simple statements, P and J. And now what we want to know is Joe telling us the truth? So we look over to Pete, we look at Jenny, and here's what we find. Pete's got a mess of donuts with him, and Jenny's smiling because she brought some beef jerky. So both of our simple statements are true. Did Joe tell us the truth? I'm going to go with yeah, he did. He told us Pete will bring donuts to class today if and only if Jenny brings beef jerky to class today, and they both brought what he claimed they were going to bring. Now let's say that this is the case, though. We look over at Pete. He's got the donuts, but Jenny's shaking her head. She didn't bring the beef jerky to class today. Okay, so now we have the statement on the left-hand side of the triple bar is true, and the statement on the right-hand side is false. Did Joe tell us the truth? And I'm going to go with no, because what Joe said was that Pete would bring those donuts if and only if Jenny brought the beef jerky. And that's clearly not the case, because Pete brought the donuts anyway, even though Jenny didn't bring the beef jerky. So it's clearly not the case that Pete was going to be bringing the donuts only if Jenny brought the beef jerky. Now let's say that this is the situation. We look over at Pete. He's empty-handed. He didn't bring any donuts with him. We look over at Jenny, though, and she's got the beef jerky. Okay, so it's false that Pete brought donuts to class today, but it's true that Jenny brought beef jerky. Did Joe tell us the truth? And I'm going to go with no, because what Joe told us originally was that Pete will be bringing those donuts if Jenny brings the beef jerky, if and only if she brings the beef jerky, and she brought the beef jerky. So it's clearly not the case that if she brings the beef jerky to class that Pete will bring the donuts, because he didn't. So I'm going to go with Joe told us something not true. Now finally, let's say this. Joe tells us that Pete's going to bring these donuts if and only if Jenny brings the beef jerky. We look over, and Pete is empty-handed and Jenny is empty-handed. Neither one of them brought what Joe claimed they were going to bring. Okay, so both of our simple propositions here are false. Did Joe lie to us? I'm going to go with no, because what he said was that Pete will be bringing those donuts if and only if Jenny brings the beef jerky. But if she doesn't bring the beef jerky, he's not bringing the donuts. And if he's not bringing the donuts, she's not bringing the beef jerky. So I'm going to go with Joe told us the truth here. And what we see, well, actually, it's better on the screen. You can find a pattern here, okay? A triple bar is true anytime the two sides match. Okay, so if you see on line 1, P and J, the two simple propositions, are both true, and the triple bar is true. And you can see on line 4 that P and J are both false, and the triple bar is true. So when the two sides match, the triple bar is true. But when the two sides don't match, like on line 2 and on line 3, the triple bar is false. Okay, and this is revealing to us the rule of biconditionals. And again, you can see this here. Lines 2 and 3 are where the triple bar is false, and that's where the sides do not match. But lines 1 and 4, the sides do match. Either both statements are true or both statements are false. And in both of those situations, the triple bar is true.